This is the Pearson Edexcel Ial, Pure Math 2. Oh, no, Pure Math 1, June 2022. And this is question 3, which deals with surds. Okay. Right, this one starts off with a little warning. This is not for calculator work. You have to show all your working. Okay. So show that this is an integer. So an integer, negative or positive whole number, and find its actual value. So let's go. Number 3, I. Oh, just I. First thing I do is split the denominator. So 180 over square root 5 minus 180 over square root 5. Okay, split up the denominators. And then because of this surd rule, so the square root a over the square root b is equal to the square root of a over b. So we know, because of that surd rule, that this must therefore be equal to 180 over 5 square rooted. And this must be equal to 80 over 5 square rooted. Okay. 180 divided by 5 is 36. So we have the square root of 36. 80 divided by 5 is 16. So we have the square root of 16. 36 is an actual square. So that's 6 times 6. So square root of 36 is 6. Square root of 16 is 4. And that's equal to 2. Just like that. Number II, it wants the answer in this form. And A and B have to be rational numbers. So it can be written as A over B, rational. Okay, let's take a look. So number 2. 4 square root 5 minus 5 all over 7 minus 3 square root 5. First thing you need to do is rationalize the denominator. You do not want surds in your denominator. The way we do this is we times it by 7 plus 3 square root 5. And of course, what you do to the denominator, you need to do to the numerator. So 7 plus 3 square root 5 on the top as well. Okay. So what do we get? Well, 7 times 4 square root 5 is 28 square root 5s. And do the outer term and the inner terms. So the 3 times 4 square root 5s is plus 12 square root 5. And the inner minus 5 times 7 is negative 35. And then we do the last. So it's going to be negative 15 square root 5. Okay. All of this over the denominator. Seven times 7 is 49. And it's the difference between two squares. So it'll be a negative in the middle. And we just do the last. 3 times 3 is 9. So there's 9. And square root 5 times another square root 5 is just 5. Oh, I think I made a mistake in the numerator here. The first is good. The outer. Okay. So we did, the outer is here 12 times, not square root 5, it'll be 12 times 5. Because square root 5 times square root 5 is going to be just 5. We're using this rule that if you have the same number times by itself, square rooted, it's just going to be equal to whatever was under the square root. Okay. Right, we have some like terms. the square root 5s, and we have the constants, 12 times 5 and 35. So this becomes 28 minus 15 is 13. So 13 square root 5, 12 times 5, and minus 12 times 5. What is that? 12 times 5 is 60 minus 35 is 25. All over 49 minus 9 times 5. Which is 4. You're not supposed to use your calculator, so 9 times 5 would be 90 divided by 2, so 45. If you're not supposed to use a calculator there. And 49 minus 45 is 4. Okay. So let's see. We have, just remind myself not to use calculators for this. 13 square root 5, splitting the denominators again, plus 25 over 4. I'm just going to check the form they wanted this in. A plus b squared 5. Okay, so this we're trying to get it into the a plus b squared 5 form. And we're nearly there. Well, basically we are there. Just 25 over 4 plus the b would be 13 over 4 square root 5. That's it. Okay, I think that was question 3 completed. Good.